All right, today we're going to deal with the concept of a limit. So, this is chapter 2, and this is going to be the start of where we really start to break down what calculus really is. So, one of the fundamental ideas within calc is the idea of a limit, okay? And calculating limits are unbelievably important because they lead us into two different branches of calculus. So, the first branch is called a differentiation or derivatives, calculating a derivative, okay? So let me just write this out, differentiation. And the other part would be integrals. Now, differentiation or derivatives, they give us ideas about velocity, acceleration, even population growth. I mean, it measures how fast something is changing. All right, so let me write this here. How fast? Let me get a little bit more specific. How fast one variable is changing with respect to. That's what WRT stands for, with respect to another variable. All right. Integral calculus is the ability to calculate the area under a curve, surface area of an object. Let me write that better here. I'm running out of space, so I'll just move over. Even volume. Okay? So like volume of an object or something like that. Now, in order for us to really dive into limits, we have to understand just a basic concept, which I'm going to be honest with you, you already know what this is. And this is called average velocity. So we're going to do a problem here that deals with average velocity. And what I'm going to do, because it's a really good example, to be honest with you, I would probably just use this example and then change the numbers a little bit. But for simplicity, I'm going to be just looking at this at your book. And it is example 1 on page, let's see, what page is this? 56. All right. And it deals with just average velocity. So a rock is launched vertically upward from the ground with a speed of 96 feet per second. 96 feet per second, okay? Forgetting air resistance. So neglecting air resistance, which is a biggie for now. If you have me for differential equations, we no longer ignore air resistance. We take it into consideration. But neglecting air resistance, a well-known formula from physics, which we've all seen before. States that the position, scroll up here a little bit, the position of the rock after t seconds is given by the function s of t equals negative 16t squared plus 96t. Okay? So the position S is measured in feet. With S equal to 0 corresponding to the ground. So that's going to be on the ground. Okay. We want to find, part A. Find the average velocity of the rock between t equals 1 and t equals 3 seconds. Okay? So what I went ahead and did is I just took our function from up above and I graphed it using Desmos here. So let me just kind of shrink this down a little bit so we can get a better idea of what it looks like. Okay, there we go. And I have the function here. I just chose to put in y because Desmos really likes y and x in terms of their variables. But just remember, this is going to be, let me use a different color here so you can actually see it. S of t, and remember, those are just the variables t. Okay? Well, anyways, let's get back to this. So, what we're asked to do is to find the average velocity from points t equals 1 and t equals 3 seconds. All right? So, what we can do is we can go ahead and just plot, okay, well, what is the position of the rock at 1 second on my function, and what is the position at 3 seconds? So right here is 1 second, and we're going to come straight up to here, and it looks like it's about there, okay? And then we're going to do the same thing for t equals 3. Oops, sorry, I mislabeled that. 1 is right here, so it's going to be right there. And 3 seconds, it's going to be all the way up there. So if we were to kind of estimate a little bit on what those heights would be, I would say this is probably 80. And then this right here is going to be 144. If you need to, you could just go back to your book on page 57, and it'll show you exactly what these points are. All right, but this is going to be the point, 1, 80. And our second point, 3, 144. And I know this is old school, but from algebra, we know that if you have 2 points, you can always calculate the slope of a line. Now, if you recall from algebra, you should recall that the slope is the rate of change between 2 points. So if I were to just create a line here, what I can do is find the slope of that line that I just created, and that would represent my average velocity in between these 2 points. Okay? So to do that, m is going to equal, and let's see here. I'm just going to make this 0.1 and 3, 144, 0.2, and all I'm going to do here is just substitute and evaluate. So 144 minus 80 equals 3 minus 1. 144 minus 80 is 64. 3 minus 1 is 2. So that gives us approximately 32 feet per second, which is my average rate of change. Okay? So, like I said, we've seen this before a long time ago in algebra. These types of problems are basically just set up and just substitute and simplify. And the average rate of change is going to equal S of T1 minus F of T0, all divided by T1 minus T0. In other words, it is going to be the position at point 1 and the position at point 2, and all you have to do is just substitute them in and just simplify. But the question becomes this, okay? What if instead of me trying to find the average velocity in between, let's say, points or time, t equals 1 and t equals 3, what if I wanted to find the time in between points 1? So here's the question I'm asking. What is the velocity, or what is the speed of the rock at t1 explicitly? So if you think about this, and like I said, you have to remember all the way back in algebra. In algebra, we learned that the slope, y2 minus y1 all over x2 minus x1. All right, we learned this, but a lot of times we are a little bit lazy. There is a very special condition for the slope, and that is x2 cannot equal x1, because if x2 and x1 are the same exact value, then you're going to get 0 in that denominator. And then as far as we know, that is just that's undefined. You can't, you really can't do that. So the question becomes, what is the speed of the rock at t equals 1 second? And that is going to be in the next video.